Hi everybody, Mrs. Gifford here. Today we are going to take a look at something called the distance formula, and by the end of this lesson you will be able to use the distance formula to find the distance between 2 points. So let's take a look at a couple of examples, or first of all the description of what is the distance formula. The distance formula is based on the Pythagorean theorem. If you're like, what's the Pythagorean theorem? That's when we have a right triangle and we have the two legs. The legs are what make the 90-degree angle, and this hypotenuse, this long one here, is c, and the Pythagorean theorem is a squared plus b squared equals c squared. And we can use this distance formula, which we haven't talked about quite yet, to find the distance between 2 points. So as you look down below here, we have our coordinate pairs of our 2 points. This here, d equals the square root of, all of that stuff together will give us the distance between 2 points. So it's just like using any other formula. You're going to take a bunch of numbers and plug them into this equation. So let's just take a look at a couple of examples, and it should make more sense to you. But basically all it's saying is you're going to square the difference of the x terms, square the difference of the y terms, add them together, and then you're going to find the square root of the entire thing. So here's our first example. We're going to find the distance between these points with the given coordinates. And our first example has the coordinate pair 4, 2 and the coordinate pair 3, -1. The distance formula is new, so we're going to practice it. To get started with these problems, we're going to write the distance formula. So d equals the square root of all of this other stuff. So it's the x from the second point minus the x from the first point squared, plus the difference of the two y coordinates squared. So in taking a look at our coordinate pairs up here, it doesn't really matter which one you consider the first one and which one you consider the second one. You just need to make sure that you are putting it all in the same order. So d equals, and for this one I'm going to choose to actually keep them in order. I'm going to use this first coordinate pair as we'll call it x1, y1, and x2, y2. And so following through with what this distance formula says, we are going to subtract our x coordinates. So we have 3 minus 4 squared plus -1 minus 2 squared. All I'm doing again is taking the x coordinates and subtracting them, and taking the y coordinates and subtracting them. So we keep the square root symbol. 3 minus 4 gives us -1, we have it squared, plus -1 minus 2, the rule for subtracting a positive, it's like adding a negative, so we get -3 squared. And now we use our order of operations. We need to square the numbers that are underneath, and -1 squared is -1 times -1, which is +1, plus -3 squared. -3 times -3 is 9, and then 1 plus 9 is 10. Now you can either do one of two things. You can leave your answer as square root of 10, or if you have your calculator with you, you can find the square root of 10, which in this case is about 3.16. So we would say the distance between these 2 points, if we were going to look on a coordinate grid, would be about 3.16 units away from each other, just depending on what our unit is. So we just say units, not inches, not feet, anything else like that. So let's take a look at a second example. Same thing with the last one. We're going to write our distance formula first. And what is that? D equals this long square root. We're going to subtract the x coordinates, square them, and we're going to add after we subtract the y coordinates and square that. So again, it doesn't really matter which coordinate pair you pick as your first one and your second one. Just to keep things easy, I'm going to leave this as my first coordinate pair and my second coordinate pair. And following what the formula says, all we're going to do is simple substitution. So get that long square root in there. And then we have -5 minus -2 squared plus negative 8 minus negative 2 squared as well. From here we're going to solve. Now we have to figure out what's inside each of those parentheses, and subtracting a negative is like adding a positive. So we're actually going to do that for both of them. And so we have d equals negative 5 plus 2 is negative 3 squared, and negative 8 plus 2 is negative 6 squared. So d equals square root of negative 3 squared is 9, plus 6 squared is 36, and then d equals square root of 9 plus 36 is 45. 45 is not a perfect square, so again, depending on how the answer choices are, then you would either leave it as the square root of 45, or you can find its square root, and that is approximately 6.71. So if we were going to look on a coordinate grid, the distance between those 2 points would be about 6.71. So one more example. Here we have an example about these two folks who live near a lake, and we've got Luana and Ken, and they're going to meet over here at the marina. A marina is a place where people store their boats. And it says Ken's going to take his boat and Luana is going to drive her car to meet up. And the first question is, how far did Ken travel? So we need to take a look at the graph. Here's Ken up here, and we need to figure out how far it is for Ken to get to the marina via the boat. So all we have to do is count how many spaces that is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this scale, because one little square represents a mile, we would say that Ken travels 10 miles by boat to get across the lake. And Luana is going to drive her car, and if you look at Luana's, she doesn't drive, you can't drive straight across all the yards and all these other things, so we have to figure out how far Luana travels. And we've got these coordinate pairs here at her starting point and down here at the marina. So if we look at this first coordinate pair by Luana's house, that coordinate pair right there is negative 2, 0. And this coordinate pair down here is 3, negative 1, 2, 3, 4, 5. So at the marina, we are at 3, negative 5. So now we're going to use our distance formula that we just learned to figure out how far it is from Luana's house to the marina. So we have d equals, remember we're going to write that formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. Doesn't matter which point we use. So I've got my 3 minus negative 2 squared plus negative 5 minus 0 squared. Again, we've got 3 minus negative 2, subtract a negative is like add a positive. So we have d equals 5 squared plus, and negative 5 minus 0 is negative 5. And so then we have 5 squared is 25 plus 25, and that equals 50. So her distance is square root of 50, and just like before, we're actually going to grab our calculator and figure out what the square root of 50 is. I know that 49 is the closest perfect square to this, and so then we actually get, I knew it's going to be a little bit more than 7, and when we use the calculator it becomes 7.07. And our measurement is miles. So for Luana, it takes her 7.07 miles to get from her house to the marina. And the last question is, how many times as great is the distance that Ken traveled as the distance that Luana traveled? It asks how many times as great. So we need to figure out how many 7.07s go into 10. So to figure that out, we need to do 10 divided by 7.07. And in this case we get about, instead of equals, we'll change that to approximately. That's what the little squiggly lines mean. Approximately 1.41 times bigger. So in all three examples, I showed you how you can use the distance formula to find the distance between 2 points. Whether you're looking at a grid, you can write the coordinate pairs, or if you're given 2 points. So there you have it, folks. Hopefully by now you can use the distance formula to find the distance between 2 points.